Okay, so we're going to start off with composition of functions. Composition of functions is a new type of operation that we use on functions. So basically, you can kind of understand it conceptually pretty basic. Now, there's a lot of things we do with it which at times can get a little confusing, but fundamentally all composition of functions is we have two functions and we take something and feed it through the first function. So we take an input, put it through the first function, and whatever comes out of that first function, we immediately feed into the second function. And then we see what comes out of it. So that's all we do is we have two and sometimes more, but usually two functions in a specific order. And we take an x, send it through the first one. Whatever comes out goes directly into the second function. And then we want to know what happens at the end. So here's our notation, and we can read this, it makes sense. This is a logical notation. You work your way from the inside out. So see how we have these embedded parentheses? Work from the inside out. So we start with an x, and we feed that into the function g. What comes out of that function then is called g of x. We take g of x, and we feed it into the function f. Okay, so we're just going to work through what that looks like. So g of x, we can see up here, is equal to 3x minus 4. So we're going to feed 3x minus 4 into the function f, right? That's what this is saying. This g of x gets replaced with 3x minus 4. Now we're going to feed 3x minus 4 into f. So just think about what if we wanted to figure out what f of 2 was. That means we would take all these x values and we would replace them with the number 2. Except we're trying to figure out f of 3x minus 4. So what that means is we're going to take all the variables up here in f and we're going to replace them with the quantity 3x minus 4. So when we go to do that, we're going to square our input, subtract 3 times our input, and then add 4. And that looks like this. We get 3x minus 4, our input, squared. That's from this x squared term. Minus 3 times our input, that's from the second term, and then plus 4, that's from the last piece. So now we just have to go through and simplify all of. So now remember with this piece, this just does not become 9x squared and this becomes 16, because where does this 24x come from? So remember, 3x minus 4 squared is really 3x minus 4 quantity times 3x minus 4 quantity. In other words, you have to FOIL that out. Okay, go ahead and use FOIL on that, and that's how we get this term. So FOIL this piece here, first, outer, inner, last, go through, do all that, and you'll get this term. Then we're going to distribute the negative 3 into here. That's where the negative 9x plus 12 comes from. And then we have the plus 4 that's hanging out on the end. And then all we have to do now is just combine like terms. We're just going to go through and clean everything up with some last minute simplification. And there we get our 9x squared minus 33x plus 32. Okay, so that's what happens when we start with x, put it through g, and then put that through f. Okay, what happens if we turn it around, right? Think about it. Some operations are commutative. For instance, multiplication and addition. 4 plus 5 is the same as 5 plus 4. 4 times 5 is the same as 5 times 4. But not all operations are commutative. Subtraction is not. 5 minus 4 is not the same as 4 minus 5. Division is not. 4 divided by 5 is not the same as 5 divided by 4. So the question that we would like to know, is composition commutative? What if I do it in the other order? Do I get the same answer? Is it like multiplication where I get the same thing? Or is it like division where we have to be really careful about the order in which we do things? Well, let's find out. So here I have the same two functions, but we are going to compose them in the different direction. So last time we did f of g of x. Now we're going to do g of f of x. So we've got our g of f of x. So that means we're going to start by taking our x and sending it through the function f. Then we're going to send that through the function g. So f of x we know is equal to x squared minus 3x plus 4. So we're going to send that into our function g. Okay, and then what we're going to do is, well, g says you take the input and you multiply it by 3 and then you subtract 4. So we're going to take our input, multiply it by 3 and subtract 4. And then we still have some simplifying to do here, although it's a little easier than the last problem. Go through, we're basically going to distribute that 3 through the problem, and then we're going to go through, looks like we have a little bit of cleanup to do with the constants there and combining like terms, and then we end up with our final answer of 3x squared minus 9x plus 8. Notice that the only thing we did different in this problem was reverse the order of the composition, and it sure looks like we got a different outcome. So we can conclude that composition of functions is not commutative. It's like subtraction and division, where we have to be really careful about the order that we do our composition, because if we do it in the wrong order, we're going to get the wrong answer. All right, so here we have a different setup. Now we're going to think about composition in terms of tables. Okay, so here I have two different functions. These are different functions than we were dealing with in the previous problem. So this is a new problem with new functions. Small functions here, just 3 points to each of these functions. But we have our function f that turns 1s into 2s, 3s into 4s, and 5s into 6s. And then we have our function g that turns 2s into 7s, 4s into 2s, and 6s into 1s. Okay, so how would we deal with g of f of 1? Okay, so remember, we work from the inside out. So I'm starting with a 1, and this says I'm going to put a 1 into f. Okay, so we look at the function f, which is this first one. And what happens when I put a 1 into f? Well, it looks like f turns 1s into 2s. Okay, so f of 1 is 2. So we end up with g of 2. F of 1 became 2, so we now have g of 2. So now I have to ask, what does g do to 2s? So we go to the function g, which is our second one here, and we see that it turns 2s into 7s. So g of f of 1 is 7. And you can see we're still just doing that thing we talked about at the very beginning. We're taking one value, in this case 1. We're sending it through the function f. Whatever comes out, in this case 2, we're sending into the function g, and we can see here that g turns 2s into 7s, so our final answer is 7. So g of f of 1 is 7. We can also do this graphically. So another problem. These are new functions again. These are not connected to the problems we just looked at, but we have f of x equals x squared, g of x equals 2x minus 4, and if I put an f of g of 3 here, we get an answer of 4. This is Desmos.com, by the way, DESMOS.com. It's free to use. You don't even have to sign up and make an account. Feel free to use this in your work. It's very helpful. We're going to be dealing with graphs a lot. So notice how it's telling me that f of g of 3 is equal to 4, but why is that? Can we figure out why it's equal to 4? Well, let's go in here. Let's see. So the red graph is f, and the blue graph is g. So I'm trying to figure out here, okay, so let's see. This says take 3 and feed it into g. That's the blue one. Okay, so 1, 2, 3. If I put it into g, that's this point right here. So I'll just mark it here so we can see it. That's the point 3, 2. Okay, so this is the function g. We're putting in an x value of 3. That tells me the y value is 2. Okay, so for g, the input was 3, the output was 2. That means we're now going to feed that 2 into our other function f. So looking over here at f, let's see, at 2, the output appears to be 4. So we can see that point right here, 2, 4. So it looks like when we feed 2 into f, 4 is what we get out. And yep, that's what they told us right at the beginning, that f of g of 3 was equal to 4. So we can play the same game that we just played with the tables. We can play it directly from the graph. And that's a really good skill to have.